To introduce myself, my name is Cole Bowden. I'm a developer advocate at a company called Firebolt. We're actually based in Kirkland, so just up the road. It's like a $12 Uber to get here. I've been at Firebolt for a little under a year at this point. I really enjoy being a developer advocate. It's a cool company. I'm going to tell you a little bit about what Firebolt is, but this talk is also made to be a little general. Hopefully it applies to other use cases. We have some competitors that you could do kind of the same tricks I'm telling you about here on if you're already using them or if you'd want to use them instead. So this isn't a sales pitch. It's more of a talk about what you can do with low latency SQL for AI apps. So the outline of this presentation, we're going to start by discussing RAG, or retrieval augmented generation. This probably isn't going to be a new term to anyone in this room by now. But in my experience, there's sometimes a little bit of confusion about it. So I'd like to align on what RAG is so that we're all working with the same vocabulary. I'm going to talk about using SQL for RAG. I think a lot of the times we assume with RAG that like vector search in a vector database is going to be the most efficient way to do that. And often the case, that's true. Vector similarity is pretty powerful, but it's not always what you want to do. And sometimes you have relational data, or you want to do things with RAG that wouldn't necessarily be well suited for a vector database. I'm going to talk about the power of low latency, so making things more interactive by providing RAG where you're not spent waiting on a backend that has to take 30 or 45 or 50 seconds to compute what you're trying to get at. And then I'll give you a demo of an app we built that kind of showcases this in action. It'll be a combination of Firebolt with ChatGPT. We've kind of just wrapped the two together with a system called Chainlit, I believe. And that'll show you a chatbot that kind of uses SQL as a backend to get you more meaningful insights on a data set. So first question, actually, I'm not going to do that slide. I'm going to ask for someone in the audience. Does anyone want to try and give us a definition for retrieval augmented generation? I'll take a hand. If you want to say it loudly, I'll repeat what you say for the recording. Yeah, add context to your conversation. I think that's pretty good. I've chosen to define it as AI and more data. In this case, data could be a blog, documentation, a website, a database, whatever you want. And the key to RAG is that a model has been trained on the whole universe of data. There is everything out there in the world that has been input into the model. But that means that it's really good at being general and not always really good at being a domain expert. So by providing more data, more insight, more information, more documentation or whatever, you can improve the accuracy of a model, you'll reduce hallucinations, and it's better for highly domain-specific generative tasks. As tech workers doing things and building new things that haven't been built before, that's sometimes very, very important. RAG isn't magic. I think you've probably done it. It comes in many different forms. Anytime you upload a document to GPT and tell it, please fix this, that's technically retrieval augmented generation. When I give it my bad Python code and tell it, please clean this up for me, that's retrieval augmented generation. It's retrieving my Python script. But it's useful. It's cost effective. It allows you to be more current. You're not relying on the year that the model was built to have your information. So if something happened a week ago, you can use a generative model with that information to make sure that you're up to date. And that makes it more trustworthy, more reliable. It's a really great way to do things. And I think most of the time you're doing generative anything, being able to supplement it with data is a super important and powerful way to go about it. So why SQL for RAG? And this is where things get a little opinionated. The biggest thing is that SQL's everywhere. Can I get a show of hands in this room? Who here has written and run a SQL query before? That's pretty much everyone. I mean, there's a couple hands that aren't up. When I was in San Francisco giving the same talk 2 weeks ago, I had a 9-year-old that had run SQL before. So that was really good at highlighting that it is a near universal technology. Relational data is everywhere. Nearly every company has relational data. It's an industry standard. We're pretty used to SQL being in places where data exists. SQL also does some things that vector databases aren't so good at. So aggregations with SQL can be fast. Time-based analysis is generally quicker. You're not relying on like vector similarity for dates. You're just going to be able to say like, yeah, I specifically want data in this range. I've got a primary key on this. I can filter for that very quickly. It's more multifunctional. You can use a SQL database for a number of different things. You can use it as a backend for a website. You can use it to power an app. So when you have a SQL database, it's doing more than just powering AI. And you also tend to have better transactionality. So in business critical use cases, you're not at risk of like write conflicts causing problems or data disappearing when you try to do a transaction. And that can be important. The more business critical your data is, the more you're going to care about ACID compliant transactions. It's simple and powerful. You're going to avoid multiple pipelines. You know, it's a vector database is never your only database, but SQL can be your only database. It's reliable, it's consistent, it's recoverable, it's less expensive a lot of the time. And once again, it's everywhere. If you want to do something with SQL, you can. Like, there is an ecosystem built on top of SQL tools that is simply immense. You can do it in any programming language. There's so many different pieces of software that run on SQL. So when you go to do something, it's been built already. Someone's done it, and that tends to make projects big and small a lot easier. And there's a lot of software and vendors out there that are trying to make your lives easier when you're working with SQL. Ours vendors are a little newer. Vendors for vector search are a little newer, and that can be tougher to work with at times. And that'll get better with time. But right now, SQL works well. So I'm going to take a dig at Elon Musk. I actually can't put the original tweet up here. You can go find it if you want. He was claiming that the government does not use SQL. Of course it does. SQL's everywhere. So I'm now going to do a little bit of a sales pitch. We're going to talk about Firebolt very briefly as far as what it offers with SQL as a data warehouse. So we pride ourselves on being a high concurrency, low latency data warehouse. That means that while we have traditional data warehouse functionality with that ACID transactionality and reliability that you expect, we're also able to deliver you analytics and queries with really quick latency. Think like faster than the blink of an eye. Some queries will be as quick as 4 milliseconds. The average query run by customers in Firebolt will return results less than 150 milliseconds. So that's very, very fast. We do that with scalability for concurrency. You can have many hundreds or thousands of users submitting queries at the same time. We recently published a benchmark result that showed us scaling up to 2,500 queries per second. So you can run SQL queries as the backend for a website and have thousands of users going through filters, selecting their data, and Firebolt is able to support that. And it's efficient because we allow you to scale to exactly what you need. There's very granular scaling, so you don't end up overspending on capacity. You can get exactly as much compute power as you need. You can auto scale up, you can scale down, you can auto start and auto stop, so you don't end up spending money on resources that you're not going to leverage. I think that's it for my sales pitch. Sorry, I had to include it because we're sponsoring the event, but I don't normally do sales pitches. So all of that said, that's kind of the world of SQL for retrieval augmented generation. And now what I want to do is move into a demo where we're using SQL with retrieval augmented generation. So we at Firebolt have built this Firebolt chatbot. And actually, I'll show you VS Code real quick to show you what's going on here. This is quite simply a Firebolt connection, a connection to OpenAI, and Chainlit connecting the two with a chatbot. So there's no magic here. Like, one engineer built this in 2 days hastily. I've edited a little bit, but like, this is not particularly scripted. I'm actually going to be riffing and asking questions and having the audience ask questions as well. So we're going to go ask GPT some questions. We have a data set that's a real data set. It's from one of our customers, actually. They're a company called SimilarWeb. And what they do is they process analytics for web traffic and search words and keywords, and where those keywords and searches end up directing on various search engines. So they were kind enough to give us a data set. It's a very finite window of data from fall of last year. I think most of the data is what they generated on like a specific day in August. But we can go look at web traffic on the internet, what people are searching for, and where they're going with it. So I'm going to have to ask or type with one hand here, but we can ask what data is available. And this chatbot's going to boot up a Firebolt engine. It's going to run a SQL query to go ask, and it's going to give us the entire schema of what's in this data set that we have from SimilarWeb. So you can click on this drop down here in this chatbot to see what's been going on. We returned a bunch of rows. I think we see like our create table statement. We see an aggregating index, a feature in Firebolt to speed up aggregations. And it's going to tell us like we have this many rows. If you look at this is kilobytes, megabytes, gigabytes, terabytes. So it's a 7 terabyte table. This is not like some super small pet table. This is a real amount of data. And then we can look at all of the data that exists in this data set, the full schema of all the information here. Some of this I don't even understand. Like, I don't know what difficulty is, but we can look at, for example, search engine, main domain, where we're clicking to, keywords that we're searching, etc. So I'm going to ask a question about GitHub. is we're at the GitHub office. What were the top 10 keywords that drove traffic to github.com? We're going to run a query. And then we're going to see a bunch of different things as to what people are searching for when they go to GitHub. I ran this an hour ago. Goodbye DPI, you can see is the second thing. You may be wondering what that is. Evidently, a lot of people in Russia are trying to bypass like packet inspections so that they can go to websites that are outside Russia. And that is a tool for that. So that's pretty popular. But you can also see, it's GitHub's pretty big, Copilot's pretty big. We're trying to download videos from YouTube is that fifth one. So, maybe not the most compelling argument. Chess, that's an open source chess website. But people looking for GitHub, they're usually looking for GitHub. We can do this again for Airbnb.com, because for some reason, when we're searching for Airbnb, we end up on GitHub. And here we see an entirely different set of data. So when we're looking for Airbnb.com, our chatbot's going to tell us, yeah, like most people, when they're looking for Airbnb.com, they search Airbnb. It makes sense. Sometimes they put a space in between. I'm sure someone who works for Airbnb would love to set the record straight and make it clear that there is no space. Our third search is Airbnb. I'm actually not sure what Airbnb is. Does anyone know what Airbnb is in this audience? No. No, why Airbnb? Let's see what the demo says here. Okay, it seems like ChatGPT is telling us that it's a common variation. Users may type it to colloquially refer to it. It's relatively interesting. And then we've got Verbo, for example. This is probably Airbnb running ads when you search for Verbo. They're going to try and target you. So maybe we can ask with this demo, like, what about organic traffic? So in the world of web analytics, you ask whether traffic's organic or inorganic. Inorganic means that it was an ad put at the top of the search engine. You're searching for something else, and a website has intercepted, put that little promoted thing on the top of your Google search results. What percentage of clicks organic for each of those keywords? So if my hypothesis is correct, we're going to see a lower percentage for Verbo. And it looks like, so when people are searching for Airbnb, Airbnb is running a lot of ads for people searching for Airbnb, is what this data is trying to tell me. But for example, on Verbo, it's most people who search for Verbo and then end up clicking on Airbnb.com are doing so because they got an ad. Makes sense, right? And we can keep asking questions. Does anyone from the audience want to ask a question about this data set? What do we want to learn about how people are being directed to one of these websites? We'll get to Q&A in a bit. I'm asking a question for this demo right now. There's a question about unstructured data, which I can get back to in like 2 minutes, but. Okay, so we have a question about what are people searching for when they want to look up headaches? We have a neurologist who's curious, what's the web traffic around headaches look like? So knowing this data set, I'm going to ask a pretty specific question about that, but we'll see how it goes. So. We're going to see this term probably may not exist in this data set. I haven't actually checked. We're going off the rails here. Okay. Well, there we go. So when we're looking up headaches, what websites do we land on? Cleveland Clinic, Mayo Clinic, Johns Hopkins, WebMD, Healthline, Harvard, the UK National Health Service. These websites make sense, yeah? Yeah. So I want to highlight real quick. I didn't really mention it, but the way this demo worked and the whole time, you may have noticed, is every time I ask a question, what's happening is I'm routing this question to ChatGPT. GPT is generating a SQL query. that SQL query is being sent to Firebolt. Firebolt is running that SQL query, returning the results through Chainlit back to ChatGPT, which is processing, interpreting those results, and then giving us these plain text answers we've been getting. So all of this has been like going back and forth through a number of different systems. And I think aside from waiting on this very last one where we searched for a relatively low frequency keyword, things were happening pretty fast. You probably didn't notice the fact that we were going from generative AI to SQL database, back to generative AI, back to the user. This was happening very snappy, very responsive. And in fact, if I ask the same question again, we can ask another question about headaches. Let's see. So now that we've cached some of the data from this with sub-result caching in Firebolt, you can see that that query happened very quickly. And this is people looking for things about headaches, you know, different types of headaches, how to have fun with a headache. Personally, I think I'm taking a nap, but maybe drinking some water. But you can see that this is happening all very responsively. And that's the power of this SQL-backed RAG that I was talking about, where you can get very fast insights about data, asking plain text questions using generative AI with a low latency SQL data warehouse underneath. So that's the bulk of my demo. I'm going to stop sharing my screen. And now we can get into Q&A. Actually, I think I have a slide for that. Do I? Yeah, there we go. Now it looks good.
Okay, so first question. Go ahead.
How often and how good is it when it's going to make multiple SQL queries? So if it needs to run multiple queries, is it pretty good at figuring out how to kind of sequence them?
Yeah, so this is kind of a limitation of like the model you're using and how you're using it. I think if you wanted to use this in a more robust fashion, you would probably add another player or two into the architecture here. So for example, I know there's like a number of companies who are out there working on natural language to SQL translators that like understand a schema and can more accurately and resiliently generate queries that will run well. GPT, in my experience, is really good at handling results. Like if you can generate good queries, like it will process, interpret, and deliver analysis on those results like quite effectively. But so the more complex you get, the more I think you would want to like specialize this by adding an extra like natural language to SQL step somewhere in here that isn't just using like I think it's like 4.0 model is what I was using for this today. But it's pretty good.
Let's say the data is a little bit more sensitive. It's security data, or it's compliance-driven data, it's data about users in a certain region, and you don't necessarily want to send all that data back to ChatGPT, you don't want to send it back to DeepSeek. What are some of the implications and what data is sent back to the model? And is the answer just run your model locally?
Yeah, no. So this is actually a great question, and it's pretty good to highlight. I'm gonna zoom out of Q&A and show you like what's going on. Is underneath the hood, I have this like environment folder that's providing my credentials into Firebolt. So Firebolt is just a SQL data warehouse. It has role-based access control. When I do this, like I have a specific user, a specific account with specific permissions to access only certain databases behind the scenes. So like if I tried to ask this model like, hey, go get all of Firebolt's customers, it wouldn't be able to because it can't see my customers database and my sales table and whatever. It's been given explicit access only to this like similar web-based web traffic data set that we have. So if you don't want the model to access a certain bit of data set, when you're connecting that model via the connector into your database, you use role-based access control. You can limit based on rows, you can limit based on columns, you can limit based on tables or schemas or databases, and that'll make sure that data that you don't want the model to see, like it can write SQL that tries to query it, but if the account it's using doesn't have those permissions, it won't be able to access that data at all.
Yep. Any follow-up question? Okay.
So let's say that you did want to give these kind of easy insights on data that is a little bit more sensitive, right? So I totally understand RBAC it to what you want to give it, but I guess how much do we have to give to the model to actually be able to get good insights, right? If it's only say we only need to give it the schema and it's only generating SQL, Are we able to limit how much we're giving back to the model afterwards?
I think that is a very tricky question. I think that so it's if we want the model to have access to sensitive data potentially, but without servicing that sensitive data to an end user is kind of what we're trying to do. I think like I wouldn't trust an AI model to do that without more oversight. I think there are companies that like do oversight layers. You can add like a filtering onto the results to check and see if it like is presenting any information that you don't want an end user to witness. That's probably a little outside the scope of this. I think like there are solutions, but it's a question of how much do you want to trust your generative model with data that you wouldn't trust an end user with. I think I personally like think from a true compliance perspective, depending on how secure and private this data is, like if it's under GDPR or it's like healthcare data, like you can't give it to the model because the end user shouldn't be able to see it either.
So you mentioned about the conversation started with RAG being something that provides the context, right? And the question answers that we had, they seemed, are they the simplest form of RAG where you're asking a simple question and getting an answer? Or is there a more complex RAG? Is there a more complex question you could ask, like a prompt? And then how would it surface the data and how many SQLs would it write?
Yeah. So if you wanted to make it more complex, you could just write a more complex question. I'll actually show you. It's underneath the hood as well. It's genuinely the wrapper we have on ChatGPT is these two sentences. Maybe I should zoom in to make that more clear. We're telling it it's a helpful assistant, and we want it to write Postgres queries to answer questions. So if you provided a multi-paragraph question asking it to give you a short essay or whatever, and write as many SQL queries as necessary to do that, if GPT did it right, like it would work. I've chosen not to do that for this demo because I was kind of trying to highlight the snappy responsiveness rather than like the true depth and robustness. This demo will be public on GitHub at some point, and if you wanted to try with that, you'd be able to. So I would encourage like asking that. And actually, after this talk, like I can sit down with you, and if you want to try submitting a question, like let's see what happens. I'm a little hesitant to do it on stage because web traffic data is sometimes a little weird, and I am afraid of servicing things I don't want to, but it could work.
Right. Next question.
I have a question related to the setup process. My understanding is to create a SQL query by ChatGPT. Does ChatGPT need to know the schema information of the database? So if I'm a new customer, I want to use this solution, how to load the data in a way that the tool knows my schema?
Yeah, so I think like it depends on where your data already exists. In this case, we have data loaded into Firebolt. Like it has been ingested into Firebolt with pure SQL, not an AI process, like just some good old ETL to get this data into a Firebolt database. When I started this conversation off, if you remember, I asked what data is available. That tipped the model off to like go fetch the schema so that it would be aware of it and have that in context for the rest of the conversation. So if you connect to a database and you ask the model, like, what's the schema I'm working with, it can go fetch that. It'll do show columns. It'll get that answer, and then it will know that for the rest of the conversation. So like it was an important step for me to ask what data is there so that there was that context in the rest of the talk.
Hang on.
You mentioned that like RAG is used pretty effectively in this individual demo. Are there other methodologies that are kind of following after RAG?
Could you expand on that a little bit?
Well, like RAG is really good for a variety of different use cases, but because we're dealing with like structured data, are there any other structured like retrieval or augmented generated options that are out there?
Yeah, I mean, like it depends on what model you want to use and what your data is. Like you can do visualizations with this. If I had started telling it like, please make a graph showing that, it can do a bar chart. In my experience, it succeeds 85% of the time. And I really didn't want my demo to air out when I was on stage. So I refrained from doing that, but like it can do that. The world's your oyster, you know, it's generative AI. Like you ask it to do something, it'll try its best. So your creativity is the primary limitation here. To get back to the question about how we handle unstructured data, that's a little harder with a SQL traditional data warehouse. We have Iceberg functionality coming soon, which handles unstructured data a little better. And it's just going to depend on like how efficiently you can retrieve that unstructured data, what specific unstructured data you're talking about. But if the data's there, if a SQL query can access it, that'll work. If you wanted to use something other than that structured data, like you wanted to also include an essay or a paper, like you could expand on the demo. You know, I had a very simple interface, but I could have like modified my UI, uploaded a like PDF or a docx file or whatever, told it like, please keep this in context too, and use that to also inform your answers. And that would have worked as well. So while this just showed specifically SQL for RAG, like you could have augmented it with SQL, this other thing, a third other thing, and used all of that in combination to ask whatever questions you want.
I noticed that the model was always, well, not the model, but the database was always responding with 10 rows, even though you didn't specifically ask 10 rows. Was that limit 10 part of the code, or is it just internally? Why is it always 10 rows? I guess that's my
I
first
think
one.
it's because I gave it this top 10 here.
Right, and the follow-up questions you did not.
I
and-
think it just inferred that that was what I wanted it to keep doing. Like,
Okay.
there's nothing in my repository telling it limit 10. If I go back here, so like, let's prove this. Let's do top 250 keywords that drove traffic to Airbnb.com. And now it's just gonna, okay. That's, it didn't wanna. If we check this, you can see the SQL did limit 250. Yeah, and the raw SQL data output now we're scrolling through, you can see all 250 rows. So in text, it chose to truncate that just to be user friendly, but like there's nothing telling it to limit 10. I just gave it a limit of 10 at one point and it chose to run with that because it was trying to be helpful.
So is the result, the raw rows from the result from the database, is that going back via the model, or is it your application which truncates the text?
It was the GPT truncated it.
Okay, so the rows go back through GPT before coming to the end.
Yes.
Okay.
So it's I submit a chat, GPT translates it into SQL, the SQL runs, the results of that query go back to the generative model, and then the generative model gives you a result. But you can see inside this used execute SQL query dropdown that we can get to.
Part of what an earlier question was, so the sensitivity, is there a way to not have it reprocessed through the model? Is there a way to directly get the rows from the database?
Yeah, you would just
Within
modify
that?
the code and you could do that immediately. Yeah.
Okay, so the second follow-up question I have is, it seems like you have write access, so can you also ask the application to create an index on a column that you are interested in querying more often?
In Firebolt, you can't add indexes to tables that have already been created. I think you can add aggregating indexes. I'm actually not sure if I have write access. I haven't done any writing. I could maybe ask it, like, do I have write access? But it might, let's see. I don't really want to mess with my database because we're going to use this for more demos in the future. So if I okay, it's telling me that I would need to go ask it to write data, which I'm hesitant to do because this data set is provided by a customer. So
All right.
yeah, I think to answer your question more generally, like yes, you probably could do that if you wanted to. Like, yeah, there's nothing stopping you from trying to write. I just don't want to do it right now, but you could.
So if you've got multiple data sets and you ask a general question about name or something that may appear in several of those data sets, does it go through a process first to decide what it's going to query against first and then build a query, or how's it work? Because right now we're working against one data set, right?
Yeah.
You've got multiple data sets. How does that decision process work?
Yeah, I mean, I'm just working with like the GPT 4.0 model.
Right.
So I would think that like some of that's going to need to be prompt engineering. Like the more complicated the universe gets, the more specific you're going to need to be in instructing it to understand the data you're trying to get at. So, you know, if I have 3 tables I'm analyzing, all of which have an ID column, like I might say like, hey, what's the ID from this specific table? And it will probably understand, interpret that, and translate that into SQL. If you're ambiguous, like the model's going to try its best. It'll attempt to interpret based on the context of the conversation which one you're referring to. There's no guarantees of accuracy. I'd say like work a little harder on your prompt if you need it to be more specific and the circumstances get more sophisticated. But you could do that. Like it's very feasible. It's just a question of how much you want to prompt it.
All right, so let's get a couple more questions if there is any. Going once, going twice. I think Cole's also going to be here after after the tech talk's over, and then the session.
I actually unfortunately have to go,
Oh no.
but I am local. I work in Kirkland. So like, don't be afraid to reach out. I'm Cole Bowden on LinkedIn. I'm on the AI Camp Discord. So if you want to talk more, I'm easy to find. If you want to see me in another AI Camp event, like I'll probably be around. I'll be attending just as an attendee in the future. So, but
Yeah. Well, then we'll definitely see you around. But since he has to leave, if you guys have any questions, I'm going to give you 5 more seconds. Going once, going twice. Well, thank you, Cole.
Thank you.
Alrighty, and then we're gonna bring up Yason, our second speaker, and he's gonna tell us about the documentation as code in the world of AI. So as we're setting up, just a quick reminder that hey, if you guys brought your own water bottles to save the environment, reduce the waste, and all that, please come to us, come talk to us, and we have a special GitHub stickers for you guys. But yeah, so if you want some special edition GitHub stickers, come talk to us about the we have your own water bottle and doing good for the planet. All right, it's on. Come on up.
Can you hear me with the goose light here, or do I need to turn it on? Turn it on. Can I join it? Can you hear me okay with this? No? Hello, hello? That's good? All right. No. Mhm. All right. Oh, let me. I'll Chrome for a second. All right. Yeah. All right. Hello, everyone. And today I want to talk about how agentic AI will allow billions of people to build billions of solutions with a concept I call documentation as code. First, we're going to watch a little educational video. Oh, there is no sound. Let me see. Well, what he's saying is the oscillation of particles is causing the gyrations of the other particles, and child is asking, can I play with it? And he says, no, you're not going to enjoy it on as many levels as I do. All right, so, and a lot of presentations, especially about agents and AI, are kind of like that. You see a cool presentation, but then you go out and try it, and you're just not enjoying it as much as the presenter was on stage. And so I'm going to try to alleviate a little bit of that by focusing a little more on limitations. All right, so I'm going to see this idea first. What I mean by documentation as code is any solution where instructions written using natural language are executed by an agent. So the agent is the interpreter of your instructions. All right, what is an agent? Dictionary definition is a person acting on behalf of another person. And in the agentic AI terms, it's a LLM-driven program that does things for you using tools. And tools are just pieces of code that it knows how to use. When you try using agents, there's a high learning curve. The LLMs produce excessive output that is hard to modify, and it's not forgivable, right? So, next slide. All right, what can we do better? And a lot of this presentation is provoking you to think a little bit differently about agents and what they do for us. So what if we're not looking for an answer? I could talk about this for about 5 to 10 minutes, but I won't. What if it's okay to make mistakes? I know some therapists who can talk about this for hours. And maybe agents are not supposed to solve every problem. All right, another way to look at the agentic AI in our world is through evolution of code. So we started with the tubes, punch cards, assembly tapes. Then we got higher level languages, frameworks, meta frameworks. And then some people decided maybe we can do no code, which is basically a graphical user interface that builds things for you. And it solved, millions of people were building millions of products with no code. And then if I don't know if the cladistics of this are correct, but documentation as code is an adjacent branch of evolution where you just write the requirements and execute. And one thing to keep in mind with the dinosaur in the picture there, just because new forms are evolving, it doesn't necessitate extinction of previous forms. So birds are dinosaurs, if you want to be technical about this. All right, so how we're going to build billions of solutions and let billions of people build them. The first challenge is always runtime performance. It's going to be slow, right? But I will ask you to kind of think about this differently. The solution is the function of the problem. So if we know the problem, we can come up with solutions, and we're going to look for something where time is not, runtime performance isn't important. So that would be like proof of concepts where you're building in something for a month or two, but nobody likes it. Nobody's going to use it. Personal projects with a small audience. Internal tooling, because ain't nobody got time for that. And multimodal zero-code solutions. And by that, I don't just mean pictures, video. The solution could be just text messaging the right person at the right time. So what makes an agent a disk agent? And so the user will only write in natural language instructions. And some of these things are really good for any kind of agentic AI. Minimize software engineering concepts, because the LLMs are good at unstructured data, and implicit algorithms. Dynamic tools, where you don't have to write code for tools, you can do other things. Human in the loop built in, that's very, very important for any agentic solution, but more so for when the LLM or the agent is executing text instructions by the hundreds, potentially. We want a consistent enough output. It's never going to be perfectly consistent. And when we got something that works, we want to iterate on it. All right, so we're going to do a little demo. We have our manager keeps bugging us about these really quick requests to get some statistical data for our GitHub repo where we keep our code. And the requirements keep changing. So it's, they keep pinging us, oh, you're a superstar, you can build this in 30 minutes, I just need this really quick, right? I don't know if everybody's had that. So we're gonna start out with a traditional solution and then transform it into a disk solution. All right. So comes up with the requirements. For the most prolific author of GitHub issues, give me the number of issues they have created. I don't know why they would want to know this, but whatever. And then given the issues, also give me the comments, how many comments they left. All right, so just trying to gather some information on this most prolific author and how engaged they are in the comments section. So we're gonna build a front end. This is our LLM generated front end. Just have a table. We make a call to our backend, get the data, and dump it in the table. We got some result. All right, so the backend, I'm skipping a lot of the code. I'm just highlighting kind of the different types of logic that you will have. So you have a loop, you have more loops and more loops, comprehensions, and a data structure that we will return so that we can dump it in the front end. All right, the result, we get this. All right, so then we decide that since the requirements keep changing, we want to make use of agents. So we find this React agent, and it's a reason, act, observe, iterate loop that was introduced by this white paper about 2.5 years ago. And with the tool calling support by LLMs, it's made a little bit easier to implement. And we're going to use a pre-built LangGraph React agent where the user provides prompt to the agent. The agent reasons about the prompt. And if it decides that to satisfy the request, it needs to make use of some tools in its toolkit, it will make a call to the tool. The tool outputs back the result. And then the agent reasons again. If it reasons that it needs to use more tools, it will keep going in this loop until it thinks it's good enough for an output, and then it will output. All right, so here's our React agent. We got to get the toolkits. So this is a pre-built toolkit from LangGraph community, and it's built for demonstration purposes only. So if you wanted to build your own, agent, you would probably want to expand this or build your own. We're going to use an LLM, and we're going to use a little function that helps us access the agent. So this is our entry to the agent, and it's going to just call this React agent. This is the pre-built one from LangGraph. And again, if you wanted to give it extra features, you'd probably want to write your own React agent. And it has the LLM, the tools, and our response format that we're expecting, that we're passing in here. And this is just boilerplate from the docs. And then let's see what our structure for our data model is. So we got the author, and this is our endpoint that we're going to hit. And we just dump our requirements here. And then call our AI. All right, so the result is the same thing, but slower. So it's quite underwhelming. So let's look at the code again. We're not using dynamic tools. The data is structured. We are using an implicit algorithm. So our prompt contains some implicit algorithms that the LLM performs for us. So there are no more loops or any other code, really, except for our agent call here. And it's not really natural language, right? And one thing we kind of recognize really quick, what couples all of the pieces together is this data structure. If, let's say, the manager comes in and says, I want to actually see the comments and whatnot, we're now again on the hook to change the data structure, change the prompt, change the front end. And it's, again, the same kind of headache. So we're not very satisfied. And of course, the manager comes in and says, oh, of course, give me some comments and issues for that prolific author. And I only want to see the author, issue title, and comments. And the issues here. All right, so now we're going to go into code. Let's see, where's the code? All right, so we have our requirements. We've added a little styling so that, and we decided we're just going to return HTML. So instead of structure, we're going to go with a more dynamic structure of HTML, which doesn't bind our front end and back end. So we're going to have server generated pages. Yes. All right, can everybody see this? All right, so now this is our code. That's our agent. Just change the prompt to say, generate HTML. And if we look at the implementation here of our route, is just pointing to our file with the prompt. So all the code is basically gone. All right, let's run this. And this morning I was messing with my GitHub and destroyed the key, and this didn't run. So hopefully this runs now, which looks like it did. Okay, so everything's working. Let's see, we're gonna run it in Chrome. And so I made the request to our endpoint. You see our prompt come in. The LLM decides to use get issues call that's available in its toolkit. It receives a result with 2 issues. It makes, then decides that it doesn't have the comments in the result, and decides to get each issue individually and see, does that contain the comments? And so these actually happen in parallel to speed things up. And then it gets the comments and generates HTML. Let's take a look at what this looks like. All right, so this is me. I'm commenting on my stuff, and there's a bot. All right, so let's see where we can take this. The requirements change again. And now we're gonna see how much we need to change. Now we add to the requirements. I only want to see the comments for that author. I wanna kind of group the things in accordion style so that I can see them better. And give me a link to the GitHub issue so I can modify it and specify this. So what's interesting here, this is a pretty loaded line of code or line of instruction, because when I came to this, I didn't realize I didn't know what my GitHub issue was and that there was no tool to provide the answer. So then I had to kind of decide, do I write a tool? Do I add it to some general context, or do I just put it into my prompt? So I decided to go with the prompt. All right, so let's get us using that prompt. So in theory, I could just change it. Just want to keep it consistent here. I'm going to restart. That's the way the Jupyter notebook is set up. I have to restart to get the file loaded. All right, so we got a new one. Let's see what happens to our requirements now. Now open it in a new tab. So if we look at this, we got the new prompt, and it's pretty much taking the same steps again. Now it's generating the HTML. It's taking a little longer because the prompt is longer. All right, so now we've got our issue. We only have comments by me, and the second issue is empty. We can go to GitHub. We are at GitHub, actually, but thanks for appreciating the humor. So that's that. All right, so let's take it a little up a notch, a little bit. All right, this is the experimental part. I just got this working after I got the rest of this working. So let's see how this works. I'm gonna shut down all the kernels. So here, we're saying I actually want to comment on the issue from my interface. And I'm describing the web page, but the key here in the instructions is I have an ACT endpoint that I describe. And I say, it's also free text. There's no structured data, or it's kind of structured, but it doesn't have to be a perfect structure for the ACT endpoint to understand this. So just kind of telling it to use plain text, because the LLM keeps trying to do something else. So you have to, a lot of times, have to repeat the instructions for it to not, go off on its own. All right, so let's see. This one, did we run this? We're gonna run this. Pointed this out. All right, let's see what happens. So we got our endpoint. All right, so it's doing the same steps, but since the HTML is more complicated, it's gonna take a little while longer. And it could also error out, but it didn't this time. So now I got this interface. I can leave a comment and hello hello from the presentation. I submit the comment. And now I have a little status thing here that updates that this was updated. And that's kind of the quick and easy way to see that it worked. But you know, if I refresh about 20 seconds later, you'll see the comment here, just like these ones. So all of these were submitted by this bot. All right, let's go back to our presentation. Is the presentation? So what did we achieve with this demo? We got user using natural language only, unstructured data, implicit algorithms. That's pretty much all we got out of that list that we were talking about before. So there's more in terms of limitations. The tool still would need to be coded. So if you wanted to do something that's not in the toolkit, or the toolkit doesn't provide the exact features like pagination, for example, may not be in there, you would have to code that. You must learn the specializations and limitations of the agent, because you know, for the presentation, I had to bounce in terms of what prompt would work and what prompt would not work and why, right? So that's not free. Runtime performance is slow. Sometimes inconsistent output comes out. It decides to use the wrong tool and then says, you know, I can't help you. So engineering rigor, security, scalability, and debugging are, you know, all very difficult and not part of this presentation or demo. All right, so for these next steps is what I'm working at Breba Apps, which is just me working there, is dynamic tools. Is we want to be able to simply drop documentation for a tool for the agent to be able to pick it up and use it. We want stateful agents so that we can do iterative development and get some output consistency. Also, actually produces much faster results too with the stateful agent. So improve human in the loop, because it's unavoidable. The human is in the beginning and the human is at the end, verifying the results. So if you have you know, a 50-step process and somebody runs with it and produces you an output, you know, I give you a challenge, give it to a human person and see, you know, if you're gonna like the result that comes out. And all right, so the question is, are we obsolete now? And I don't know, there's still a lot of stuff to do. There's a lot of code to be written for the agents. There's just learning about communicating with agents. Retooling for AI is something that very few people are working on. For example, terminals and browsers are not built for these agents. So you're running into really silly challenges where, you know, that with just a little engineering, or a lot of engineering actually, you could overcome. Documenting for AI, you know, a lot of the documentation is written for humans to absorb, but the AI actually works better with something that's closer to, you know, Web 1.0, where it's just text and images, not like JavaScript and things folding, unfolding, and navigating through things. So also we need better LLMs. So most LLMs are not great when it comes to instructions. Even the instruct models that have the name instruct in them will not follow instructions, even, you know, when they're the first thing in the instructions, sometimes. All right, so just to conclude, with disk, users will write specification and the agent just runs it. We will solve problems rarely solved before. This is supposed to be humorous, developer setup instructions. A small website for your party that maybe 20 people will attend. Tennis league at work, you know, you find a new job that falls apart. Behavior tracking app for your child that the teachers are just not going to use. And there's billions of other highly personalized problems that you could solve given this kind of access and tooling. All right, so that's the end of the presentation. The presentation is on GitHub, and there's my LinkedIn as well there.
All right, thanks, Yason, showcasing the interesting project and the yeah. I think if you guys have any questions, let's do some Q&A. And excuse me. There you go.
Thank you. It was an awesome presentation. I think agents are definitely the future. It's a very exciting time to kind of be in this space. Have you leveraged model context protocol at all from Anthropic? And if you have, do you have any opinions on that?
No, I haven't used the
Okay.
agent context.
It's a framework to kind of make a simple protocol that all developers can follow to connect models to tooling. And then it has there's a whole bunch to it, but I would look at that up, get your thoughts on that.
All right.
Yeah, definitely +1 on the MCP. You can do a lot with that. Okay. See the second question? I'm just getting steps in.
I know you made a mention to the natural language processing, and but the question that we're asking, they're still very SQL-like, right? So what is this? Give me 10 of that. I mean, that's what we have been doing since Oracle 2.0 timeframe, last 30 years. Have you seen the use where pictures can be shared and the model can do something with the pictures? Or music can be, a music note can be shared and it can do something with it without having to say whatever.
Yeah, actually, one of the ways people are solving the fact that web browsers are not very great at working with the agents is by pictures. So, for example, the OpenAI computer use tool basically captures screenshots of your screen and tells you, and then executes on instructions to click on things based on these pictures. And I've tried it out. The one that's I haven't tried the one that's in the API, but the one that's out there that they use is actually very good at finding really small details. Like I took a picture of a ski binding that had the DIN setting that I couldn't see with my eye or barely could see from that distance or in that picture, and it was able to describe my DIN setting on my on my ski binding. So the pictures is they're really good at handling pictures.
Okay.
I'd just like to add to the previous conversation. So AWS, they just launched something called Nova Act, and which can now automate browsers with LLM. So essentially, you can write a Python script to ask it to do stuff, and it will just open the browser and do it without having to screenshot. So it's much faster than the previous approaches.
Okay, yeah, I haven't seen that one. Oh, who does that, did you say?
AWS just launched it.
Oh,
It's
AWS.
called Nova Act.
Okay, cool.
Yeah, I think that's a very similar to like OpenAI's operator mode, and there's a open source model called or open source repo called the browser use, and does a similar. It just basically say that, hey, here are the actions I want you to take and interact with the actual web UX. But let's get back to the Q&A. You had your question?
I have a comment. I was very excited with agents last year, but I think one of the challenges that most of the frameworks for agents are still in 0.8, 0.2, 0.3 versions. And when you start using them in production version, it becomes very unpredictable. And so that comment that you mentioned is very relevant. But as I was building my app, I realized that it may be better for me if I knew what tools to use. If there's a deterministic way of using those tools, it's better to create deterministic algorithm that is using tools and LLM based on your flow rather than having LLM decide when to call which tool and deal with that uncertainty at real time. So what I'm trying to say is that not every problem maps to that LLM based tool calling, and that is something that I learned as I was building my app. Hopefully as the platform develops, there's a little more certainty about how often, when, which tools are going to be called, and if we have control over control over that layer, I think then I feel agents sort of progressing more into real world situation in where, you know, you want sort of more certain output. But that's just my thought.
Yeah, that's a very good point. So in this demo, it's just one way you could do this. There's many, many different ways. They have different drawbacks, and I have run into where I need to use a deterministic flow, and then I leverage the LLM when I need non-deterministic flow. So I'll use a framework. I've mostly used the lane graph, where I'll have some deterministic things that I know I definitely need in this way. And then when I have, you know, potentially the user says, oh, there's a problem here, and they report a problem, then I just go to the LLM and say, hey, what is this? What's happening here, right? So you can like highlight text on the web page, and the user just says, and you know, provide a button or free text entry and say, you know, explain this, and the LLM can explain this, even though the rest of your app has been running in a deterministic fashion.
Cool. All right, next question.
Hi, I was reading the code you put on the screen sharing, and just want to double confirm, was the agent something you created yourself, or you are using an existing OpenAI RAG agent?
So I was using a pre-built React agent from LangGraph.
Gotcha. Okay, so my question is, in my mind, the agent requires some reasoning capabilities that we gives a why and what question, and agent will figure out how and the task and perform the task. So I'm thinking in a real life scenario, I'm trying to get some advice from you on certain activities in the context of our enterprise. Maybe we want the agent to perform certain activities in the frame of a company's policy or whatever the contract. So I see a play of RAG. The agent plays on a certain context. It's not just fully unbounded. So how to bound the agent with the reasoning capabilities in the context of a contract that we limit the agent to do? Do you have any source to share?
So I don't have a specific source code to share, but you would basically combine potentially either a tool where the getting the RAG data is via a tool for the agent, or kind of expanding on this React agent by giving it a deterministic flow where before it gets to the React agent or after, or even in the middle of that flow, you could add more predetermined routes to get RAG processed, pre-processed, post-processed, or you know, anything else. So this is a super simplistic one that was for demonstration purposes only.
Great. All righty, one more question.
Hi. So I was also just looking at the code. So I was surprised at how brief the original prompt was. And so did the model have the context of it was within a within a Flask app? Or did it not even need that context because of the Pydantic kind of format that you imposed on the prompt?
So the Pydantic format kind of makes it a little bit more complicated in that sense. But no, it didn't know anything about the Flask app. It just, yes, I can show you the code, but basically it's that prompt saying you're a web server, you know, you're not talking to a person. So there's a lot of repetition of you're not talking to a person, do not produce markdown, and that's it. It doesn't know anything about any setup, except for the step 4, where where I introduced an ACT endpoint, and I had to explain to it that there is an ACT endpoint that it can use.
Okay. So do you know what would have happened without the Pydantic format?
So Pydantic format is to provide structured data. Structured data is kind of a solution that agents are using now to connect to legacy systems or systems that require structured data. That you pass an LLM that you're expecting this format, and it produces that format for you. and then you can parse it with the Pydantic data. So it's just to introduce some consistency as far as formatting. Because
Okay.
let's say up to like half a year ago, the LLMs were, producing JSON was a huge problem, and now it's almost solved.
Okay, I got it. So do you think it would have rendered in the front end okay, even without that?
Yeah, so the last pieces, we completely got rid of structured data, and it was rendering HTML.
Okay, got it. Thank you.
Awesome. Any other questions? Going once, going twice. Up.
I noticed that you were using two different models from OpenAI in your query. Is that correct in the code?
Yes.
One was GPT-4o and one was O1 Mini.
Yes, very good observation. So that's one of the tricks I learned is for things that don't need a lot of output. And if you looked at the prompt for the ACT agent or the ACT endpoint, it just says, do not do anything or do not output anything, minimal output. So I had to repeat this. I don't know, it would be kind of funny to look at it, but where was that? But yes, so the mini agent or the mini model is because it's faster. So when I'm submitting things, I don't need reasoning. I don't need anything. I just needed to pick a tool and do it.
All righty. Last call. Going once.